Okay, we'll do one last problem and then we'll close the section. Okay, now this is theta. Fine, the mass is m. Suppose this is m1, this is m2. Theta is given as 37 degree, and you know what you have to do. Everything is frictionless. Both the surfaces are frictionless. The surface between the two wedges are frictionless, and everything is smooth. So what's going to happen? This m2 is going to come down and this m1 is going to slide to its right. You can feel that? So suppose the vertical velocity of m2 is v and the horizontal velocity is u. You have to find the relation between the velocity v and u. The relation that you must have found using the same concept that we did in the previous question, that there shouldn't be any relative velocity with respect to the plane perpendicular to the plane of the wedge. Along this line, there shouldn't be any relative velocity. V will be downward. The answer, by the way, is 4VB is equal to 3. Oh, this suppose is B and this suppose is A. Then according to that, I'm saying 4VA is equal to 3VB. This is what you must have got. Okay. Okay. Now let's see how we will be getting this. This angle is 37 degree. So V cos 37 degree. How much is that? Cos 37 degree is 4 by 5. And this is the velocity U. So U sin 37 degree. Sin 37 degree is 3 by 5. These should be equal because there shouldn't be any relative velocity. So the V is, this I told you A, right? So V is VA. 4 times VA is equal to 3 times VB. Okay, now suppose I ask you, what is the acceleration of wedge A and wedge B? This is the relationship between velocity, but what is the exact absolute value of the acceleration with which VA will be coming down and VB will be going towards left? Find the acceleration of VA, find the acceleration of wedge A and wedge B. Okay, so you got to find two things. Find acceleration of A and acceleration of B, and find the normal reaction that is between both the wedges. So get me these two things, and that will complete this section. This is important, this part. These both are important. So finally we'll be closing off the section, so you must get your answer finally this time. So I'm giving you the answer, you just check. If acceleration of A, did you get as 9 by 25 g, and acceleration of B, did you get as 12 by 25 g? Did you get normal reaction? Did you get as 4 by 5 times mg? This should be the value of normal reaction. These two should be the value of acceleration. All you have to do is write the equation of motion for this block and this wedge and this wedge. Use Newton's second law. Net external force in vertical direction should be mass into acceleration. Net external force in horizontal direction. This block is moving just because of normal reaction. So normal reaction will have a vertical component and a horizontal component. Vertical component is not going to do anything. There will be certain counter vertical component of normal reaction from the ground. But the horizontal component is going to move this wedge to its left, and that is the net force. And that net force should be equal to mass into acceleration. And you will get this if both are of same masses. I'm sorry, don't take it as m1, m2. Take both the masses, take the masses of both the wedge as m. Then you're going to get this simple answer. Otherwise, it's going to be ratio of m1 and m2 will appear here. But nevertheless, if you take the mass of wedge, both the wedges same, then you will get these answers. And how did you find this? This was not difficult, right? So to summarize what we have studied up till now, we have studied just one equation of motion, F is equal to ma, and we have played around with that.